Okay, POE, after our 9 weeks test, which probably will start on Friday, the stuff after the 9 weeks test, that is. Today is the last day of the 9 weeks testing, so we won't be doing a whole lot today. Tomorrow, though, we're going to start talking about mechanical system efficiency. And we have constructed winches, and we're going to use those winches to be able to do some calculations. Now, there is a little bit of a difference here because we're going to start talking about the work, the power, and the energy consumption of the motors that we've installed onto the winch. So we're going to be using a little bit of the formulas involving the work equation, the energy equation, and let's just kind of go through this in general. The introduction says, energy cannot be created or destroyed, but energy can be converted from one form to another. By design, an engineer creates an energy conversion system to change an input energy form into a desired output energy form. What we're going to be doing is we're going to be taking electrical energy and we're going to be turning it into stored energy due to gravity, because we're going to be taking an object and we're going to be picking it up using a winch. I'll have videos once we actually do it in class, and I'll show you digital students so that you can actually gather data for this lab, or for this activity. I guess physics would call it a lab, but we're engineers. It's an activity. Let's see here. So the winch and material system will need a permanent marker, multimeter, stopwatch, and a variable power supply. We got all those. No big deal. Okay, let's see here. Confirm all connections and parts are functioning correctly. So for digital people, part one, it looks like this is all going to be on the people in class, making sure that the power supply is actually on, making sure everything works. Then what we're going to do is we're going to get two weights, and we're going to attach two weights to the winch. We're going to get the mass in grams, and then we're going to convert those masses in grams over to newtons. If you don't know how to do that, grams to newtons, what you're going to do is you're going to divide by 1,000, take your number of grams and divide it by 1,000, and then multiply it by 10, which is acceleration due to gravity. I'll make a lecture on that, and I'll post that on here too. This is really just an explanation of what's going on with the assignment. Then we're going to attach the weight. We're going to mark the winch cable with a marker so that we know how much distance we're going to be covering before we need to stop. It's kind of important that we make the same distance that we travel every time if we want our measurements to be accurate. And then from the bump switch, what we're going to be doing is we're going to start the winch using the button, and then we're going to stop it whenever it reaches the mark. And we're going to record the voltage and the current displayed on the power supply. Well, I don't think we're necessarily using those power supplies this year. We've got the voltage, and if we can find the resistance, then we can calculate the current, but I may get dangerous and decide to use the current meters instead. We'll find out and see what happens. The current meters make me nervous because people just end up blowing them up. And then what we're going to do is we're going to record that information. So the mass, the newtons for that mass, the voltage, the current, and how long it actually took. In order for us to calculate the power of a motor, we're going to need the time that it took in order to be able to do it as well. So then we unwind the cable and go back to normal, and we're going to add a second weight, and we're going to repeat step 5 using two weights instead of one weight. So obviously the mass to be lifted, we're going to add those two masses together. So if we're talking about force, we're going to be taking a force and exerting that force over a specific distance. So to find the work done in this, it's going to be the distance that we lifted up the weight itself, and we're going to be multiplying it by the force of gravity. So it's the force of gravity times the distance itself. Just in case I said the same thing twice. So force times distance. In this case, it's the resistance force, or the weight of the object, that we're going to be using for the force. It's the force of gravity. So whenever this winch is going up, we're saying that we're doing work against gravity, because gravity is wanting to pull it down, and we are taking that object and we're pulling it up. So power involves force, time, and distance, and there will be a formula applied to it. By the way, if you use the one on Canvas, what you want to do is you want to go to the top up here, and you want to click this dock at the top, because that document actually has all of the pictures inside of it too. It'll make your life a lot easier. That way you won't have to be like, Mr. Broadway, what is the formula for power? And it's because they give them all to you. So work is equal to force times distance here. Down here for determining the power output of the system, your power is equal to your work output divided by your time. Now, the work output that we're going to be getting is a experimental value. It's going to be values from data that we've gathered. We can also do the theoretical value, which is just using pencil and paper. We can calculate if everything was 100% rainbows and butterflies and unicorns farting rainbows, and there was no friction in the world, we could calculate how much work it should have done. But what we're going to find out in real life is that the work that actually got done is going to be a little bit different just because of the voltage and the current outputs. It should give us a different value. Okay, we can also use the power. There are two different ways to find power. One of them is work output divided by time. This would give you kind of a theoretical value. Okay, and then using the instruments that we've measured using current and voltage, that will give us a more realistic value of what's actually happening in real life. So if we take the current in amps and the voltage in volts and we multiply them together, we should be able to get a power rating for the motor. So to find the efficiency, like how efficient is your motor, how well is it using the energy that you give it on a scale from 0% to 100%. If it is 100% efficient, you need to get a Nobel Prize because there's no such thing as 100% efficiency. That would mean that you would have no friction whatsoever, which is impossible to do. So the efficiency is going to be the power output, which is always going to be a lower number than the power input. And then you're going to take that decimal that you're going to get, and you're going to multiply it by 100. If you get a number that's over 100%, you have done something wrong. This is not magical stuff. You have literally done something incorrect. It is impossible to get something to have more energy than what you put into it, unless it's getting that energy from somewhere else, but that's a story for another time. Okay, so this is the general idea of what we're going to be doing. This should take us a little, probably a day to go through. I don't think it's going to take too long since we've already got the winches built. The conclusion questions list and describe three factors that reduced efficiency. So think about what could actually be slowing it down. What would make it not 100% efficient? There are lots of answers. 13, describe one strategy for making the system even more efficient. Okay, so use your noodle and try to figure out how you could actually make this work better. And then explain two or more reasons why automotive engineers are concerned with eliminating inefficiency from vehicles. So think about that one and then answer that one in the conclusion questions. Whenever you turn this in, you can fill in this sheet, blah, 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 and you can turn it in. Just make sure you don't turn in a blank document because what's been happening recently is people have been like thinking that they've turned it in, but as it turns out, they're just really just turning in the blank document itself. The way that you can fix that is you can rename it because whenever you download it, it's going to say 1.2.5 A.VEX mechanical system efficiency. Why don't you just call it like your name and then 1.2.5? That way you'll know that that's the one that you're turning in. And instead of, it'll help you prevent from making blank assignments. And it'll prevent me from giving you zeros and sending them back and saying, hey, redo this. So that's what we're going to be doing on Friday. Have a great day, and I'll talk to you guys later.